Okay, so you should have cubbed question 9 and used Circar. And if you haven't, please do it now and pause the video. Otherwise, let's go through the answers. So, a box is dropped out of a hovering helicopter. The box has a mass of 60 kilograms and is dropped from a height of 0.6 kilometers. In your answers, assume the acceleration due to gravity is g is 9.8 meters per second squared. So question A, calculate question the gravitational potential store of the box before it is dropped. Okay, before it is dropped, that's key. Use the equation. Gravitational potential energy equals mass times acceleration due to gravity times height. Write your answer to two significant figures. Okay, so what? Let's see. My line down there. And then let's see, what do we need in this equation? We're working out gravitational potential energy. So we need the mass. So mass is equal to, what does it say? 60 kilograms. Okay, that's fine. I like the units. Can leave it in kilograms. We need the acceleration due to gravity, which is g, and that's 9.8 meters per second squared. And we need the height. Height is 0.6 kilometers. Okay, kilometers is not a normal unit of height, so I'm going to change that to meters. Remember, k is just the same as times 1,000 meters. So I'll rewrite that. That's 600 meters. And just by doing that, I've got 1 mark right there, because this is a 3-mark question. Okay, so again, it's going to be slightly more difficult than just plonking the numbers into a formula, and that's where the extra mark has come from correctly identifying that the units of height are incorrect. I'm then going to substitute my my values into the equation. So I've got GPE, just use shorthand there for gravitational potential energy. GP equals mass, which was 60, times acceleration, which was 9.8, times by 600 equals 60 times 9.8 times 600 equals 352,800. So I'm not a big fan of the fact that these calculators use commas. Sometimes you see a comma at the bottom, comma at the top, and I know that quite often when we write numbers, you like to put a number like this, you might put a comma there. I would urge you not to, only because a comma looks very much like a decimal point. So if you want to block the numbers up into groups of 3, leave a little space like I do here. There's a much clearer way of writing it, and also make sure that you don't the examiner doesn't mistake a comma for a decimal point, or you don't. Write your answer to two significant figures. So I need to write this to two significant figures. So it's 350,000, and it's energy, so it's in joules. Okay, so that was part A. Let's have a look at part B. Could you circle part B, please? Okay, so B, it's a calculate question. The weight of the box. Using the equation, force equals mass times acceleration, and it's worth 2 marks. Okay, so let's see what we've got. So we've got the weight of the box, force equals mass times acceleration, so the mass is equal to 60 kg. The acceleration in this case is an acceleration due to gravity. It's 9.8 meters per second squared. So we know that weight, which is W, so I'm going to transfer it across now. They're my two values. The equation almost acts like a shopping list. To make force, I need mass and I need acceleration. And I know that it's force I'm looking for. force, weight and force. Remember, weight is a force due to gravity. So weight is mass times acceleration, so it's 60 times 9.8 equals 60 times 9.8 equals 588. 588 newtons. I'm just going to quickly check that it doesn't say to two significant figures or anything funny like that. No. So it's only a 2-mark question. The 2 marks here, one is for identifying correctly the values I'm going to use, and the other one is for the answer. That's it. Okay, so could you have a go at cubbing C, please? Okay, so this is a describe question. What happens to the gravitational potential store of the box as it falls? And it's worth 1 mark, that's all. So what happens to the gravitational potential store of the box as it falls? At 1 mark, I'm only going to say something simple. So what happens to the GPE as it falls? The GPE decreases. So the gravitational potential store decreases or gets less. Okay, and the reason it does that is because it's not as high up, it gets less high. Okay, D, please. Could you have a go at just cubbing and answering D? Okay, so what does it say here? So explaining what happens to the kinetic store of the box as it falls, and this is worth 2 marks. Okay, so a little bit more. We're not describing, we can't just say it goes up, it goes down, what does it do? We've got to also say why. So it's worth 2 marks, so 1, 2 bullet points. So the first thing is what happens? Well, it increases. So the kinetic store, it gets faster. Kinetic store increases. Well, why does it increase? As energy transferred from gravitational store. So remember here, what we've got our stores. So in this case, gravitational store of box. It's a box falling, isn't it? Yep. Of box goes to 2 things: the kinetic store of box, but it also goes, if you remember, the thermal store of box and surroundings. That's always, we always get thermal store increasing, and the thing it travels along, this thing here, is a pathway, and in this case it's a force, which is weight moving. So this will be the mechanical work done pathway. Okay, remember 8 kilograms cement, that's the stores, and the 4 pathways for Mr. He. Okay, so we're always looking at how does, when anything happens, energy is moving from store to other stores, of which thermal store is always one of the surroundings, and it moves via pathways. So transferred from gravitational store via the mechanical work done pathway. My handwriting's dreadful, sorry about that. Work done pathway. Okay. Right, once you're done, question 10 please. Could you look at it, cub it, and if you need to circle it, then please do.